Factoring out a greatest common factor and the grouping method. Well, we know the difference between terms and factors. Terms are separated by addition or subtraction. Factors, multiplication, division. We've already reviewed how to multiply polynomials. For instance, 3x times x squared plus 5. Distribute that 3x gives us 3x cubed plus 15x. So factoring out a greatest common factor, basically, we're working backwards. We're beginning with a binomial or a polynomial like this and getting it back into factored form. For the steps for factoring out a greatest common factor, make sure the polynomial is in standard form. Identify the number of terms. Then identify the greatest common factor in each term. In other words, what factors every single term in the polynomial have in common. Factor it out, or in other words, divide each term by that common factor, and then take a quick check at the end to make sure you actually did choose the correct common factor. In other words, the remaining terms do not have any other factors in common. So example 1, notice no equal sign, we're not solving. Directions are to factor out the greatest common factor. We only have two terms. It is in standard form. So what we could do to help us understand the factors, once again, is put it in prime factorization. So 11x to the fifth, 11 is a prime number. X to the fifth, we know that exponent 5 is multiplied, tells us x is multiplied by itself 5 times. The second term, negative 33, negative 3 times 11, if we break 33 down into its prime factors, and x squared is of course x times x. So the factors that these two terms have in common, they both have an 11 and they both have two x's. So the greatest common factor, 11x squared, that's what we're going to divide each term by or factor out. If we pull 11x squared out of the first term, what we're left with is 3x's or x cubed. If we pull 11x squared out of the second term, we're left with minus 3. We began with two terms, and that's not going to change. We still have two terms inside the set of parentheses, but now that they're smaller, we see that they do not have any factors in common. And we can still take a step further and check ourselves by distributing that greatest common factor back inside the polynomial, the set of parentheses, to make sure you get the original answer, or the original problem, excuse me, and we do. Number 2, we have three terms. So identify the greatest common factor. In this case, we want to figure out at least how many x's each term has and at least how many y's. They all three terms have at least two x's and at least two y's, so that's our greatest common factor, x squared, y squared. If we divide the first term by it, what we're left with is 3x's and 3y's, in other words, x cubed to y cubed. The middle term, the y's eliminate, leaving us 1x, so plus x, and the third term, the x's eliminate, leaving us 3y's, or minus y cubed. So still have three terms inside the set of parentheses, and now we see they do not have any other factors in common. Example 3. Once again, three terms, but we notice this is not in standard form, so that's the first thing we want to do is rewrite it in standard form. Negative 27a to the fifth plus 9a to the fourth plus 18a cubed. So we certainly have some common factors, but by putting it in standard form, what we also notice now is that the leading term is negative. We never want the leading term to be negative in a polynomial, so if we do have a negative leading term, we're going to factor out a negative along with the greatest common factor. So begin with the coefficients. 27, 9, and 18 are all divisible by 9. And not just 9, but a negative 9. As we said, we factor out a negative. Then go on to the variables, the a's. They all have at least 3a's. So the greatest common factor, negative 9a cubed. Divide the first term by it. What we're left with then is 3a squared. The second term, negative a, and the third term, negative 2. So still have three terms inside the set of parentheses, and we see they do not have any common factors, so we factored the correct greatest common factor, negative 9a cubed. Example 4. Now if we're simplifying, of course, we would want to distribute the x inside the first set of parentheses, distribute the 4 inside the second set of parentheses, but we're asked to simply factor. So overall, we only have two terms. Two terms being added together. So within the first term, we have two factors, x and 4x plus 3. The second term, we have two factors, 4 and 4x plus 3. So from these two terms, obviously we have that common factor, 4x plus 3. So that's our greatest common factor. That's what we're going to factor out. If we factor it out of the first term, we're left with just that x. Factor out the second term, we're left with that plus 4. So it factors into 4x plus 3 times x plus 4 by factoring out its greatest common factor. Factoring out a greatest common factor is an important step in factoring. It's something we're always going to check for. We may not always have a greatest common factor, but like I said, we'll certainly always check for a greatest common factor. Which brings us to our first actual factoring method, called the grouping method. We use this method when we're factoring a polynomial with 4 terms. So we want to make sure it's simplified, in most cases anyway, not always, but in most cases. See if we have a greatest common factor, make sure it's in standard form and so forth. Then what we're going to do is we're going to group the first 2 terms together in parentheses and the last 2 terms together in parentheses, making sure we have a plus sign between the 2. So that's why it's called the grouping method. And then what we're going to do is factor out the greatest common factor from each set of parentheses. So let's look at example 1. Obviously, we have 4 terms. We do not have a greatest common factor. Now, usually, of course, we see those 2 middle terms are like terms. We would want to combine them. But just for practice, we're going to leave them the way they are, because if we did combine them, we would no longer have 4 terms. We would only have 3 terms of trinomial, which we haven't covered how to factor yet. So, grouping method, what we're going to do is we're going to group the first 2 terms together in parentheses. We're going to group the last 2 terms together in parentheses, making sure we have a plus sign between the 2 sets of parentheses. And we do. So now we're going to factor out the greatest common factor from each set of parentheses. The 4 terms together did not have a greatest common factor, but now just the first 2 terms have a greatest common factor x. We factor it out. The second set of parentheses has a common factor 9. We factor it out. And if the grouping method is going to work at this point, the 2 sets of parentheses should be the same, and obviously they are. Now at this point in the expression, we only have 2 terms, 2 things being added together. They both have the common factor x minus 6, so we're going to factor it out. What we're left with from the first term then is just that x. What we're left with from the second term is that plus 9. So it factors into the 2 factors x minus 6 times x plus 9. Example 2. Polynomial with 4 terms. It is in standard form. We do not have any greatest common factor. So 4 terms, of course, we're going to use this grouping method once again. So group the first 2 terms together in parentheses. Group the last 2 terms together in parentheses, making sure you have a plus sign between the 2, and we do. So just looking at the first set of parentheses, we have a greatest common factor, 2x squared. We factor it out. What we're left with, x minus 6. The next set of parentheses, greatest common factor, 5. Factored out, we're left with x minus 6. So the 2 sets of parentheses are the same once again, x minus 6, and it just happens to be x minus 6. It's not always going to be like the previous problem was as well. Either way, factor out that common factor, x minus 6. What we're left with from the first term is that 2x squared. From the second term, the plus 5. So now we factored this polynomial. We're left with 2 factors, x minus 6, 2x squared plus 5. And example 3, we have 4 terms once again, and just like the earlier problem, we're not going to combine those 2 middle terms. We'll leave it the way it is, so it remains a polynomial with 4 terms, but we do want to check for a greatest common factor, which we do not have one. What we do notice about this problem is that the third term, negative 5x or minus 5x, means that if we were to put parentheses around the first 2 terms and the last 2 terms, we would have a negative in between the 2, which we always want a plus sign. So what we know is that we can change any subtraction problem into an addition problem. For instance, x minus 5 is the same thing as x plus a negative 5, and that's what we're going to do to that third term. Rewrite it as x squared minus 8x plus negative 5x plus 40. So therefore, when we put parentheses around the first 2 and last 2 terms, we have a plus sign in between the 2. So factor out the greatest common factor from the first set. We're left with x minus 8. The next set of parentheses, by having that negative now in front of the 5, we see we're not just factoring out a 5, we need to factor out a negative 5, leaving us x minus 8 again. Having that plus sign in between the 2 basically reminds us that we're not just factoring out a negative from that third term, but also from the fourth term, making it a negative 8. So therefore the 2 sets of parentheses are the same, x minus 8, and what we're left with then is the remaining terms, x minus 5. So it factors into the factors x minus 8 times x minus 5.